So we will continue with the transactions. We have already seen what a transaction is, what a schedule is, and some recovery control systems, etc. So we will next move on to concurrency control protocols. So concurrency control protocols are essentially, that is what they decide how to manage the concurrency between two or more transactions in a schedule. So the locks, etc., and when to give access to of a particular data item to a transaction. That is what we will be studying next. So this is about concurrency control protocols. Fine. So one of the ways of ensuring concurrency is through the use of locks. We all know that locks are what OSs also use, operating systems also use to ensure concurrency, and the databases are no exception, they also use lock. So locks are what that access the control. So this control the access to a data item, and the requests of lock are essentially made to, there is a module in the database which is called the concurrency control manager. So this is the module in the database that handles this concurrency control protocols and handles the locks, etc. So all requests for locks are made to this concurrency control manager. The concurrency control manager decides whether to grant the lock or deny the lock. If the lock is granted, then the transaction essentially acquires that lock and goes ahead with that operation on the data item. If it denies, it can actually wait. The transaction generally just waits till it is granted later by the concurrency control manager, and then it goes away. One very important thing is that the operation of locking a data item by a transaction, as well as the operation of unlocking the data item by a transaction, these two operations must themselves be atomic. So it cannot happen that two transactions are trying to lock a particular data item, so only one of them will get the lock, or it may happen that none of them gets the lock, that is a separate issue. But so these are by itself atomic operations, the locking and unlocking, just the operations by themselves are atomic. So either a transaction completely gets the lock or it does not get it. So two transactions cannot get the same lock. Even if they request almost at the same time, there will be some ways of ensuring that only at most one of the transactions get the lock. So then a data item may be locked. So a data item is what it's locked or unlocked. A data item may be locked in essentially two modes. The first one is called an exclusive lock. So this is denoted, so exclusive lock, this is denoted by an X. So essentially this means that data item can be both written as well as read. So if a transaction obtains an exclusive lock on a data item, then the transaction can both write and read to the data item. The other type of lock is the shared lock, which is denoted by S, which means the transaction, if it obtains a shared lock on the data item, it can only read. So write, data item cannot be written. So it can be only read by the transaction. So these are the two important things, the exclusive lock and the shared lock. And then there is a lock compatibility matrix. So there is a lock compatibility matrix that essentially defines the compatibility between the different kinds of locks. So which means that suppose there are two transactions that are also all locking, etc., we will be assuming on the same data item, otherwise there are no conflicts and there is no issue. But suppose there are two transactions, the row denotes one transaction and the columns denote another transaction. So the point is, if there is some transaction which has got shared lock and the other transaction wants a shared lock, can it get it? Yes, it can get it. Suppose one transaction has got a shared lock and the other wants an exclusive lock, can it get it? No, it cannot. So similarly, if one has got the exclusive lock and the other wants a shared lock, it cannot. And of course, if one has got the exclusive lock, the other cannot get the exclusive lock. Now this should be very intuitive as to what is happening. This is essentially to guard against the conflicts with write. So if there are two transactions that both of them want to write to the same thing, which is both of them are wanting that X lock, that cannot get it. Even if one of them wants to read and the other is writing, the other transaction will not be able to get the X, the shared lock, because the other has got the exclusive lock. The only case where both of the transactions can get is both of them wants to read the data item, in which case there is no conflict. So both of them can just obtain a shared lock, which is why the S to S matrix, the entry for S to S is yes, and they can just go ahead with doing that. So the read there is no conflict. This lock compatibility matrix does just encodes the conflict that we have already studied. So that's the thing. Okay, and as I said earlier, that if a lock cannot be granted in this case, it will be just wait for that. Okay, fine. So using all these locks, we will next move on to the locking protocols. So the locking protocol is essentially how the transactions must be granted locks so that the concurrency can be maintained, and there is no issue with the correctness. So the correctness of the schedules will also be maintained. So we have seen that the schedule, we have already seen that the schedule specifies all the read, write, and maybe the abort and commit operations as well. In a locking protocol, a schedule must also mention explicitly all the locking and unlocking operations. So it must say that transaction 1 wants a lock, etc., and so on and so forth. Now essentially we cannot guarantee whether the locking or unlocking has been done, because that is done by the concurrency control manager. So what it essentially tries to do is to request a lock and then unlock, that is it. So now that is denoted by in the following manner. So when a transaction, so this is Lx of 1 of a transaction. So this notation means that transaction T1 wants, so transaction T1 requests an X lock on data item A. So that is the meaning of this. So that is why it is called a lock X. So L stands for locking, X means exclusive lock by transaction 1 on data item A. So that is the notation Lx1 of A. So transaction T1 requests X lock on A. Now when you say Ux1 of A, essentially it means that transaction T1 releases the X lock on A. So these are the things. So it either requests or release. Then similarly there is this Ls1 of A, which means transaction 1 requests a shared lock, S lock on the data item A, and then there is an Us of 1, which is transaction 1 releases the S lock on A. So these are the 4 types of operations that will be added to the schedules in addition to the read, write, and abort, commit, etc., to specify the locking and unlocking of these operations. Alright. So for example, schedule can be simply specified in the following manner. Let us just go over briefly what does this mean. So essentially it means that first the transaction 1 requests a exclusive lock on A. Once it gets it, otherwise it must wait. Once it gets it, it reads A and then writes to A. Then transaction 2 requests a shared lock on B, which will be granted if there are, assuming there are no other transaction things, because this is on a different data item, and there is this exclusive lock, and this is just a shared lock on B which has got nothing to do with it. That is granted. Then it reads, because it has got a shared lock, it can only read, it cannot write. So it only reads, which is fine, and then this transaction 1 releases the exclusive lock and transaction 2 releases the shared lock, and that is the end of the schedule. So that is how our schedule will be specified in this. Okay. Now let us see an example of what needs to be. So this is all fine as a schedule. Now let us consider another schedule and see what may happen with such a schedule. Now note very importantly what we are doing here is that the following. Okay, so transaction 1 wants an exclusive lock on A. Assuming there are no other transactions and assuming there is nothing else going on, this lock will be granted because there is no conflict, nothing. So transaction 1 gets that lock, only then it reads and then writes. Transaction 2 requests a shared lock on B, again that will be granted because there is no problem, then it reads. Now what happens is that transaction 2 wants an exclusive lock on A and transaction 1 wants an exclusive lock on B. Now the important thing comes is that transaction 1 is already holding an exclusive lock on A. Okay? So unless transaction 1 releases it or unlocks it, transaction 2 cannot get another exclusive lock on A, because that is what it is not allowed by the lock compatibility matrix. So it will not be getting it. So it will keep on waiting. So transaction 2 at this point will keep on waiting for the exclusive lock. On the other hand, transaction 1 wants an exclusive lock on B. Now transaction 2 holds a shared lock on B, it has not yet released it. So transaction 1 wants an exclusive lock, again this is not going to be allowed and this will keep on waiting. So now essentially what is happening is here is very important. Transaction 2 keeps waiting for an exclusive lock on A, which it is not going to get unless transaction 1 releases. Transaction 1 on the other hand is waiting for a exclusive lock on B, which is again not going to be granted unless transaction 2 releases. Now you see this is the classic deadlock situation, right? Transaction 1 wants a lock which it is not going to get, and unless it and it's not releasing other locks, and transaction 2 wants another lock which is again it's not going to get, so it is not going to release other locks. So both the transactions are just waiting for locks on the other transaction 2, and none of them is going to release it. So it's the classic deadlock situation. So the concurrency control protocols, whatever this protocol in the schedule, etc., the locking unlocking may result in deadlock. I mean it only says when to request for a lock, it does not mean that the lock is got immediately. So it only requests for a lock, and depending on the concurrency control manager it may or may not get it, and especially something is that it can never violate the lock compatibility matrix. So if there is another transaction that holds an exclusive lock, it cannot get another exclusive lock or shared lock in it, and if another transaction holds a shared lock, it cannot get an exclusive lock in it. That is the lock compatibility matrix. So it may result in deadlocks. Now otherwise what will happen is that there may be a violation of the correctness. So the concurrency control manager will never sacrifice on the correctness, I mean it will not grant these locks. So what will happen is that there may be the situation of deadlock. Okay, that is the one thing. The other thing is starvation or live lock, that is another phenomenon that may also happen. So what is essentially is the phenomenon of starvation or live lock is that suppose there are many transactions and transaction 1 holds a lock on some item A. Now both transaction 2 and transaction 3 wants it. As it happens that once transaction 1 releases it, transaction 3 grabs the lock, so transaction 2 does not get it. Now before transaction 3 releases it, transaction 4 again wants the same lock on the same data item. So once transaction 3 releases, transaction 4 grabs it and transaction 2 again does not get it. And then again before transaction 4 releases, transaction 5 wants it, so transaction 2 again does not get it. So essentially there is no deadlock in the system, in the sense that the transactions are proceeding. Some of the transactions are at least proceeding, it is not that all the system is halted, but transaction 2 is starved. It is starved. Why is it called starvation? Because it is not getting the lock that it wants, some other transactions are getting it. So that is the phenomenon of starvation and live lock, and that can also happen if these schedules are just requesting for locks and releasing it, that can also happen. So that is the point of schedule. So then what it is being done is that now what we are going to next study is this, what is called the locking protocol. So essentially the locking protocol will try to specify how a transaction should request for locks and how it should release the locks such that the correctness is not violated. So that is the locking protocol that we are going to study next.